Everyone, we're now on our next video in the statistics, in the introduction to statistics, that is. So here we're going to continue our video with our lessons in regression, and in particular, we're going to calculate here the regression line. So, uh, so in calculating the regression line, we need to consider this equation. So this is our y hat equals a plus bx. Okay, where the meaning of these variables here is that the y hat is the predicted variable of y for our specific value of x. So this is where we can predict values already of our y given this specific x that we want to put into. We can also think of this as the average or expected value for all the persons whose income is x when we are going to take note or consider in the business setting for business statistics, we're going to take note of the setting of this as an income or business perspective. So what is this b? This b is presented in this equation. So this is n times the summation of x times y minus summation of x times summation of y all over n times summation of x squared minus summation of x quantity squared. So this is a kind of, I think you can see this in the formula of the um, Pearson R. Similar, but it's not the same. Okay, take note. It's similar, but it's not the same. Usually as you can see, the numerator is similar. Okay, and our A is equal to y bar minus b times x bar. So remember, our x bar is the mean, right? So the mean for all for all the values of x. For y bar, it's like the mean for y. All right. So here, x is for the average of the x's or the x variables. That's the mean for the x, and y bar is the average for the y. So let's take note of this example here. This is our example one. We will be determining the equation of the regression line that best represents the relationship between the region's average income and expenditure for 2009. So we're presented here a table of all the regions here in the Philippines. For example, we have the average income and we have Y as the average expenditure. Why did we say that? Since expenditure depends on income, then we say that X is the independent variable, that is your income, since expenditure depends on that. Hence, the dependent variable is going to be the expenditure then. Okay, then we're going to solve this using Excel, of course. If you have your calculators there, you can use that. But of course, it's going to be more handy if we're going to have the Excel with us. So let's do and solve this using Excel. So in Excel, I've already transferred the files um, here. Okay, so we can see here the average income and the average expenditure, which is taken from the table in the presentation before. So first, I want to show you. I have something that I forgot to show you during the last video. That is um, that is how do we create a scatter plot for this? So I want to answer that now. So let's highlight everything here in this values, including the the what do you call that? The labels. If you want, click on the insert, and then you may want to click on this the XY scatter, and click on this and click on the scatter plot. And then you can see this is the scatter plot of our table here. Okay, so you can just rename the title of the scatter plot. You may want to entitle this as the income and expenditure profile. Uh, let's say by region. This is way back 2009, so you may want to use that as your title, but the title is really it really depends on you. You can change it any time you want. Okay, so that's how you create a scatter plot for this given data here. Now, what we want to create is we need to get the regression line of this. Let me put this aside. You may want to you what we want to get is the regression line, right? So let it be like that for now. Okay, so we want the regression line. So we need in our formula. If you can remember, our formula is y hat equals a plus bx. Let me go back. Let's go back to this slide here, and we want to show you the formulas and everything that we need. So that we just need to get that if we need it. So um, clearly we need the um, summation of x and summation of y, and then summation of x squared and the summation of x well, there's no y squared, but we need this the summation of x times y. So we need first to get the x squared in each of this. Well, we want to equals and then click on this and then square it. So raised to 2. Okay, so b cubed is, or rather b3, that's this SL, and then raise it to 2. That's gonna give us this one, and then we want to use that to all of the x's in this column here. So we want to drag that. Put your cursor on the lower right part of the cell until your cursor becomes a black crosshair, and then drag it down all the way here. Okay, so that's all the squares for the x squares. So we may want to change this name into x, or name it as x, and then now we're going to name this average expenditure as y. Okay, and we need to um extend the table so that we can see the variables. So this is our x squared. um I'll just put it like this. Okay, so that is x squared. Next column we need to have the xy, so that's the x times y. So that's this cell here times, we'll use the asterisk for times in Excel. That's shift 8, and then multiply it by here, and then hit enter, and then we're going to drag it all the way down, and then we'll have all the products of x times y all the way down. And then oh, well, before that we may want to see back in our example before we can continue. And our example doesn't have any Philippines here, any whole Philippines. So I think we need to delete the Philippines in our example. So let's delete this column here. Let's just hide it for now. We don't really need it. Hide. Okay, so that's it. And then we want the x, summation of x and summation of y, summation of x squared and summation of x times y. So the summation is just the sum function. And then now we're going to sum all of these, close parenthesis, and hit enter. Okay, and then we want to copy this in all of the we need to get the sums of all the columns here. So we just click on this cell and then drag it all the way here. And then we can see the sums. Okay, and notice just one thing for my classes. Notice in this cell here, it's kind of different from our module, so kindly have a check on that. All right, now let's continue. We need to get the x bar and the y bar, so that's just getting the mean, the means. So we want to get the mean here, average of this x. Okay, hit close parenthesis, hit enter. So that's 112. We want to make use of only two decimal places, so we want to get hit number, and then we only want two decimal places for our examples, and then we're going to drag it here. We need to get the sums of the y, so that's 98 94, sorry, 94.88. Okay, then we want to have the number. How many are they? So how many regions do have? Let's just make use of the count function. This is your our n counts. How many are they? So there are 17. Okay, so meaning from the here we're going to make use of the formula of b. Formula of b is this one. So as you can see, that's n times the summation of x times y minus summation of x times summation of y, all over n times the summation of x squared minus summation of x quantity squared. So sorry, can I take a note on that? I have my notes here also, so take a screenshot. Again, then let's follow that. Let's make use of this formula here. So we'll call this our b, and our b is equal to n. Let's make use of close open parenthesis first. This open parenthesis will be our numerator divided by our denominator, so that we won't get a sorry. Okay, so that we won't get lost. So n times the summation of xy. This is the summation of xy. Okay, minus summation of x times summation of y. Okay, so that's our pretty much our numerator. For our for our denominator, we want the n. It's our n. Okay, times the summation of x squared. Okay, minus the summation of x squared. Okay, and let's hit enter. That will be the value of our b, and um we only need two decimal places for that. Notice the value of b is changed because, well, for those in my class again, the value of b is changed because the value of our x squared is changed from the from the from the handouts. So kindly take note of that. That's our b. I want to put this in the right part so that we won't get lost. And we want to get the value of a also. So the value of a, I want to put it here. And remember remember a as this. Okay, a is equal to the mean of the y minus the times b, or the b is the value here of the b that we got, and then the x bar. Okay, so what's the value of our a? Again, we have the y equals our y bar, that's the mean of the y, minus our b values, that's 0.86 and change, times our x bar. So 112.65. I'm gonna hit enter, and then it's going to give me um, negative 0.23. Okay, for the value of our a. So I want to change that to uh, lesser decimal places. That's gonna give me negative 2.24. All right, so that's gonna give me negative 2.24. Okay, so we can get now the regression line using these values of a and b. Remember our regression line to be y hat equals a plus bx. So we had got the value of a, we got about the value of b, and our x is the independent variable, our y hat is the dependent variable, and we can have our y. Maybe we can write it here. Um, our y prime. Okay, just this is y prime. Okay, oh, sorry, y hat rather. Y hat is equal to negative, um, well, that's a, right? Yeah, a. So negative 2.24 plus 0.86. Okay, times x. So that's our, this is pretty much our formula for our regression equation. Okay, take note, this is y hat. I cannot do that in Excel, I think. Okay, so just imagine this is y hat instead of y. Okay, so that's our regression equation. Okay, so what are the comments for our regression equation? Our a is equal to um, negative 2.24. Okay, so if a person has a zero income, for example, if this a region has zero income, he or she will still have to spend um, negative 2.24 times 1,000. So that's roughly 2,240 pesos. So maybe that's because of a loan. So you need more expenditures you need a lot an income to have this expenditure. So it depends on your, if your income is zero, you still need to have this expenditure, maybe from a loan. Your B value is 0.86. So for every 1,000 pesos a person earns, he or she will spend 850 pesos. That is 0.85 times 1,000. Okay, 0.85 times 1,000. Okay, and then given a particular income value, which is our x, the amount that a person is expected to spend can be determined by substituting the value of x in the equation. So that is, we can already predict or extrapolate what are the values of the y given a particular x on this equation. So this is like a function. Okay, so input a value for x, and then it will give you something in return that is a value for y. So take note, the regression line can have different values for A and B when computed manually and when using a statistical software application like Excel. So this is due to the necessary rounding off of values when manual computation is done. So we have done a lot of rounding off when we do manual computations. So hence values can vary greatly due to rounding off errors. Okay, so as an example, you'll use Excel format for this. How do we get this in Excel? So we can actually get this from Excel. Let's go back to this scatter plot that we created a while ago. And we can get the formula here actually. Okay, how do we do that? You can just click on this, click on the dots. Okay, kindly click on the dots. We don't need that. Just click on the dots. We right click on that, and then we want to click on add trend line. So when you add a trend line, there are options that will come up here, and you may want it to be where was that? You will want to make it I'm sorry, let me do that again. Format trend line, and then you want to make it linear, and you don't need the other options. What you want to do is to display the equation on chart. So if you want that, you will see the equation pretty much from this part. Okay, so this is our equation, pretty much the same as our equation here, only that by commutative property. So this becomes 0.8622 x, which is the same here, minus 2.2392, which is similar here. So that's the equation using Excel. You can just right click and then you'll have the values or the equation itself. Okay? So it's very important that the regression equation is generally valid only with the range of values x of the given data. Care should be practiced when extrapolating, that is, getting beyond this range, as it is not known whether the linear relationship is still valid or has changed. So it's pretty much much care is needed when you have that. So that's how we do it in Excel. Again, there's a shortcut. Right click on the scatter plot, and then right click on the dots, and then click to add a trend line, and then of the you'll have the values of the equation line. Actually, you can generate the equation line afterwards. Um, After that, we'll move further in the next batch of videos. We can click on display R squared value. We will know that the meaning of that in the next few videos. But in the next video, I'm going to give you one more example on how to do um, the regression using Excel. So meaning if you want to get the value, for instance, we don't have any value for 200 here, so you want to predict what's the value for 200. So what you need to do is just plug in 200 here. Okay, just plug in 200 in the x, and then you'll get the y hat. So the y hat will give you the expected expenditure if your income is 200. Okay, if your income is 500, you can get the expected y, or the y hat, by plugging 500 in this equation. Okay, and that's it for this video. That's how we get the regression equation using Excel, manually using this, and using a trend line in the plots. So thank you very much, and I'll do another example in the next video. So see you.